Hello mga ka-learners! It's Teacher Carmela. In this lesson, you will learn about the difference between mass and weight. Do you know how heavy you are? If you want to know how heavy you are, you should weigh yourself on a weighing scale. The number that you read from this device is your weight. But did you know that you could be heavier or lighter depending on where you are? Your weight when you are on the top of a mountain is different from your weight at ground or sea level or on the moon. This is because the pull of the earth differs in each of these places. Did you know, however, that your weight may vary but your mass remains the same no matter where you are? This lesson will help you understand better the concepts of mass and weight. After this lesson, you should be able to explain the concepts of mass and weight, differentiate between mass and weight, and solve problems involving mass and weight. The concepts of mass and weight are two related ideas. This is why one is often confused for the other most of the time. But in spite of their being very much related ideas, we must be able to draw the line between the two. Mass is the amount of material present in a body. And since no two things are made of exactly the same material, we can say that mass is a unique property or an intrinsic property of an object. Anything that has mass exerts an attractive force on any or other object. This force pulls the other object toward the center of the first object. The strength of the force depends on both the masses of the two objects and their distance from each other. The bigger the mass of an object, the stronger the force it exerts on the other object. The farther an object is from another, the weaker the force it exerts on the other object. For example, the Earth, having a very big mass, exerts a very strong attracting force on everything on it. When you throw an object in the air, it goes down and hits the ground after some time because of the attractive force of the Earth. This force is also responsible for keeping us from falling off the Earth. This force that is exerted on an object by the Earth is called the weight of the object on Earth. Weight is defined to be equal to the mass of the object, m, multiplied by the acceleration due to gravity, g, where g is equal to 9.81 meters per second squared for Earth. That is, weight is equal to mass times acceleration due to gravity, or W is equal to mg. Note that the preceding equation gives us a new unit of measurement. By getting the product of the mass, which is in kilograms, the acceleration due to gravity, which is in meters per second squared, we arrive at an answer in kilogram meters per second squared. When astronauts travel into space, their bodies do not experience any change. Their muscles do not change or shrink. In other words, they maintain their mass. An astronaut will have a different weight on the moon, but his or her mass will be the same. But why is this so? If you can recall, anything that has mass exerts an attractive force on other objects. The moon, though lighter than the Earth, has a very big mass and therefore exerts an attractive force on other objects as well. However, the mass of the moon is much smaller than the mass of the Earth, so we can expect that the force exerted by the moon to be weaker than that of the Earth. Therefore, if an astronaut goes to the moon, he or she will weigh lighter there than he or she does here on Earth. Now that the concepts of mass and weight are clearer to you, you can now solve problems involving mass and weight. Study the following problems. Example 1. A poultry farm sells chicken at 80 pesos per kilo. If a customer bought 4,800 worth of chicken, how many kilos did he or she buy? Solution: we will use a 5-step procedure for solving this problem. Step 1. Write down the given facts in the problem. A kilo of chicken costs 80 pesos. The customer bought 4,800 worth of chicken. Step 2. Note what is asked in the problem. Find out how many kilos of chicken the customer bought. Step 3. Write a number sentence that will give you the answer you are looking for. We are looking for the number of kilos bought, which we will represent with K. Multiply K by the cost of chicken per kilo and equate it with the amount paid by the customer. 80 pesos times K is equal to 4,800. Step 4. Now solve for the unknown. To solve for K, divide both sides of the equation by 80. Step 5. Make a conclusion. The customer bought 60 kilos of chicken. Example 2. After successfully accomplishing his mission, an astronaut weighed himself on the moon before deciding to go back to Earth. He discovered that he weighed 90.2 kg/meter per second squared on the moon. Assuming that the acceleration due to gravity on the moon is equal to 1.64 meters per second squared. What is the weight of the astronaut on Earth? Solution. Step 1. Write down the given facts. G on the moon is equal to 1.64 meters per second squared. W of the astronaut on the moon is equal to 90.2 kg/meters per second squared. Step 2. Note what is asked in the problem. Find the weight of the astronaut on Earth. Step 3. Write a number sentence for the problem. First, we need to find out the mass of the astronaut. We will then multiply this mass with the acceleration due to gravity on Earth, since the mass of the astronaut is constant whether he is on the moon or on Earth. Step 4. Solving now for the weight of the astronaut on Earth. Step 5. Therefore, the astronaut weighs 539.6 kg/meters per second squared on Earth. Let's remember, mass is an intrinsic property of an object. It is the amount of matter present in an object. Weight is the force exerted by a massive body, such as the Earth and the Moon, on other objects, such that this force pulls the other bodies toward the center of the massive body. Weight changes with location. Mass, however, remains constant. The weight of a body in a particular location can be computed using the formula W is equal to m times g, where W is the weight of the body, m is equal to the mass of the body, and g is the acceleration due to gravity, where on Earth, g is 9.81 meters per second squared. And that marks the end of our first lesson on mass and weight. If you want to know more about this topic, stick with us on the next lesson. See you!